Hi there. In this video, I want to show you how to do an independence test using the conditional rule. Okay, so we've used the multiplication rule before, but this time we're going to use the conditional rule. So what is the conditional rule? We studied conditional probability. That's when we have this given bar in here. That's what the vertical line means. This is the probability of B given A. Well, if the event A, if the given part doesn't have any effect on B, then they would be independent. So in other words, if the probability of B given A is equal to the probability of B, then A and B would be independent. So knowing that event A occurred does not affect the chance of B occurring. So this gives us a nice independence rule or independence test. And this one I find to be more intuitive than the multiplication one. So a couple things before we get started. Just like in the multiplication rule, the equal part is for theoretical probabilities, because in theory, everything's perfect. You can have two things that are equal. With empirical data, we have variation. So it would be pretty rare for the two sides to be exactly equal. So we're looking for, if they're close, they're independent. If they're significantly different, they're dependent. Okay, and again, how close? That's a judgment call for right now. Okay, let me get to the test. And before I write out the notation, I want to just kind of do it intuitively. Think about, in this case, we have three different groups, right? Two different treatments and a placebo group. We might be interested in, well, let's either the relapse column or the no relapse column to know how that varied based on each treatment. So let's just take the relapse one since we were using that earlier. If I compared 10 out of 24 with 18 out of 24, with 20 out of 24. Now these won't always be the same. It's a little easier to compare when they are. And then we could also compare with the sort of the average or the total that had a relapse out of all the participants. If we compared those percentages, that would tell us how each treatment compared, right? And tell us if they were significantly different, then there's a dependence there. Or if they were relatively close, then it would be independent. So that's really a conditional test. So I like to just write these out in a pattern. I'm going to go 10 out of 24. And I'm going to compare all of these. We could do just one, but it's even more meaningful to compare all of these. So 10 out of 24 compared with 18 out of 24, with 20 out of 24, I'm saying, are these the same as 48 out of 72? I'll write out some notation after we do this, but I bet you want to know, so let's find out. So 10 out of 24 is 0.4167. I will leave the symbol blank for right now since we don't know what's going to happen. 18 out of 24 is 0.75, quite a big difference there. 20 out of 24 is even bigger difference than the zipper mean, 0.833. And then the overall, or kind of average, 48 out of 72 is 0.6667. See, that's like the average of all these numbers. Okay, so these look, comparing all of these and knowing this one will be in the middle somewhere, this seems to vary quite a bit, doesn't it? So this is telling us how many people had a relapse given each treatment. So the dizipramine was actually the lowest. Placebo was the highest. So, and this was in the middle. So it does look like these treatments are having some effect, which, you know, it's a very small sample size, of course. So I'm going to say not equal because they're pretty far apart. And again, this part is the judgment call. So that's why you explain your reasoning, and I'm going to accept either answer depending on, as long as the reasoning is correct. So let me write out the conclusion here. The probabilities are significantly different so the treatment type, there's lots of ways you could say it, but I'm just going to say is not independent of whether someone had a relapse. I could have started with relapse. Whether someone had a relapse was dependent on the type of treatment. That's a little bit better way to say it. Okay, now if you really want to do the notation, you don't have to on this, but if you really wanted to, let's look at it and how it would follow that rule. Okay, so let's look at the probabilities we found. So this one here, remember the given part, we use the row or column total of the given condition. So this disipramine is going to be given. So this would be the probability of relapse given they took disipramine. And the middle one would be the probability someone had a relapse given they took lithium. And the green is the probability that someone had a relapse given they were in the placebo group. And then the total is overall the probability that someone had a relapse. So notice how if we put this up here, that is our conditional test. We're really testing the probability that someone had a relapse given whatever treatment. Is that the same as the probability they had a relapse overall? And then it's just very interesting to compare all of the cases. So in this case, it made sense to do the column and go across like that. In other cases, it might make sense to do a row, in which case you would be going down that way. So just make sure you follow the same pattern all the way throughout the table, and then you'll be fine. You could have also done the no relapse column, and then it would have been 14 over 24, 6 over 24, 4 out of 24, 24 out of 72. So there are multiple ways to do it. Again, it's still kind of a crude test because we're not using the entire table, but it gives us a good idea what independence means and how we might for that. All right, thanks for watching, and I'll see you in the next video.